This is going to be our lecture video for November 6th. Get out your notes and go ahead and sketch a scale that looks like this. And we're going to see what can we say about the value of x. So this scale is not balanced. It is tipping to one side, which means that we cannot figure out exactly what x is. There's a lot of different weights that this could be and still have it be tipping to this side. We don't know by how much it's tipping to one side, just that this side is heavier. But that doesn't mean we can't say we don't know anything about x. We can still make a statement about its possible values. And we can do that still using inverse operations. If I take 1 off of both sides, all right, this side will be a 13, and this side will be just an x. So although I can't tell exactly what x is, I can say that x is lighter than 13. So I don't know what it is, but if it was heavier than 13, then this side would be weighed down. So I at least know the upper bound for what x could be. And it can't be equal to 13 or else this would be balanced. So I can say that's, definitely lighter than 13. It could be 12, it could be 9. But at least I have a boundary. It's not like it could be any number. And sometimes that's enough. That's all that we need to know about a problem. So our goal for today is to be able to solve inequalities using the same skills from last unit. And why are we doing this? To solve in situations where the two sides aren't balanced. Here we've got another inequality. Now this time the left side is weighed down more. We're going to try to figure out the weight of a blue square. Well, I can still do things like subtract 4 from both sides, and it's going to stay unbalanced in the same direction. I don't want to draw 3 blue squares out, so I'm going to write 3x, where x is the weight of a blue square. On this side, it becomes a 9. And now I need a new symbol because I don't want to have to draw an unbalanced balance every single time. So the symbol we're going to use is like a little alligator that wants to eat the heavier side. So this side's weighted down more. This side is a bigger number. So we put this little alligator in here that wants to eat the bigger side. This is called a greater than symbol. All right, now we can divide both sides by 3. And we can get that x is greater than 3. We don't know what x is, but we know that whatever it is, it must be bigger than 3. All right. So let's practice facing that alligator the right direction. All these problems are in the worksheet that I handed out in class. All right, between 1 and 3, I'd rather with the 3. Now when I have 2 negatives, you actually want the smaller negative. Think about money again to make sure you're doing these right. Would you rather be $5 in debt or $19 in debt? Well, you'd rather be $5 in debt because you're less in debt. Between a negative and a positive, you always want to choose the positive. And the same thing we see over here. Okay. So, true or false? Now look, the symbol's already in there, but is it facing the right direction? Well, we've got a negative and a positive. It should always pick the positive, so this one is false. Here we've got 2 negatives. It's picking the smaller of the negatives. That is true. Negative 2 is greater than negative 3. This one here is also true. And then 8 is greater than 8. This is false. When we use this symbol, one of the sides has to be bigger than the other. There is a different symbol that would make this one true, and that is to do this greater than or equal to. Now it's true. Because with this, it says, okay, now there's 2 ways for this to work out. Either the left side can be bigger than the right, or the 2 sides can be equal. And that's 2 ways for it to be true. All right. So now, written down with algebra, here we have some inequalities. We're going to try to solve these. And we're just going to use our same 6 steps to solving. There's just one small, tiny little caveat. And that's whenever we multiply or divide by a negative, we need to flip the inequality. But looking at these four, that's not going to happen in these four. So let's just practice. I've got constants on both sides. I want to move them away from the variable. So here I've got n is greater than or equal to negative 14. And I'm done. I've isolated the variable on one side of the inequality symbol. Here, to get rid of that divide by 18, we've got to multiply both sides by 18. And I get that n is greater than or equal to, let me get on my calculator for this one, negative 18 times 8 is 144. This negative up there, so it's really negative 144. That being negative does not mean that this symbol flips. The step itself has to be negative. So nothing flips here, and we're left with n is greater than or equal to negative 144. Here we're going to add 11 to both sides. We are going to do something a little bit different with number 15 here. When we get to our inequality where the variable is isolated, we want to switch it around so that the variable is on the left. When we do that, the inequality switches so that it's still facing the 14. It still wants to eat the 14 wherever it goes. And let's look at our next one. Multiply both sides by 20, just like this one up here. And we've got 120 is greater than r. Flip it around, r is less than 120. Put a circle around it. Now these are a little bit harder to double check. You have to pick a number that is less than 120 to double check with. So you can pick like 119, plug it in, make sure you get a true inequality. And you will. You'll get 6 is greater than 5.95, and that does balance. All right, let's skip to some even harder ones with 25. Let's follow our 6 steps to solving. I'm going to distribute that negative 2. I get negative 16b plus 16 plus 4b is greater than or equal to 100. Combine like terms here. Get negative 12b plus 16 is greater than or equal to 100. Take away the 16. Negative 12b is greater than or equal to 84. And here's where that one special rule comes into play. I've got to divide both sides by negative 12 to get rid of this coefficient. But I just divided by a negative, so that flips the inequality. So now I've got b is less than or equal, let me double check this one, 84 divided by 12, it's 7. So it's less than or equal to negative 7. Now we can put a box around that. All right, let's try 26. So distribute that negative 5. And we get 15 minus 30m plus 4 is less than or equal to negative 131. Combining like terms, we get negative 30m plus 19 is less than or equal to negative 131. Move our constant away from the variable. Subtracting 19 from both sides. Now we've got negative 30m is less than or equal to negative 150. Divide by negative 30, and again our special rule is activated here. We just divided by a negative, so we need to flip the inequality symbol. We get m is greater than or equal to a positive 5. And we can go ahead and put a box around that. All right, 2 more. Requires some distribution. A negative 12 plus 24n is greater than negative 132. Constants on both sides. Should move away from the variable. Now we got 24n is greater than negative 120. Divided by 24, divided by 24. Here we did not divide by a negative, so we don't flip the inequality. It's just n is greater than push it with -5. Double check that real quick. 120 divided by 24. Yep. All right, again, I see parentheses, so I got to get rid of distribution. 10 minus 10n plus 7 is greater than or equal to 97. Combining like terms, now we got -10n plus 17 is greater than or equal to 97. Subtract 17 from both sides. -10n is greater than or equal to 80. Divide by -10, divide by -10. Our special rule is activated. N is less than or equal to -8. Alright, we'll call that good for this lecture video. I'll embed a few more for you to type your answers in for here, and have a great rest of your day.